Hi guys, I gave you guys this packet along with another one with some notes and just some worked out examples so that you guys could see. A lot of this is review, but I wanted to kind of go over a few examples for you since I know that I'm not there and I want to make sure you guys can finish these with confidence and get really good at factoring. It's really a key to any kind of math class that you're going to take from here on out. Just a review, when you see a difference of two squares, that means there's a perfect square here and a perfect square here, and there's a minus sign in between, hence the name difference of two squares. It factors out to a product of a sum and a difference. So you just take the square root of the first term and the second term, you add them together, and then you subtract them, and that's your difference of two squares. Always remember to take out the greatest common factor first, no matter what. I forget it all the time. So sometimes you have to go back and take out the greatest common factor. Some of the things that you may not be familiar with, or as familiar with, I should say, is a difference and a sum of two cubes. So if you have two perfect cubes, which is why one of those things that list of perfect cubes and squares and fourths and stuff might be useful to you as we go into this next unit as well. If these are two perfect cubes, they factor out. What you do is you take the cube root of the first term and the cube root of the second term, and you have a plus b, the cube root of those two, the sum of those. You square a, you subtract the product of a and b, and then you square b, which is the second term. Okay, I have some examples here, but I'm going to also walk you through them, some other ones as well. And then we have a difference of two cubes right here. The only difference is that you start off with a subtraction instead of addition. These are all addition, but if you notice up here, there's one subtraction sign right here. Okay, so be really careful with that. It's kind of a formula, something that you should really just, the more you use it, the more you write it out, the better off you're going to be. Okay, so I went over some greatest common factors, difference of squares, and then regular trinomials. And if you don't like these X puzzles, you do not have to do them. You do what's right for you, okay? One of the things I wanted to show you is, do you see how when I factor this out, this is a difference of two squares right here. So I have to take this another step. So I have n to the fourth plus 6, and then I have n squared minus 2 and n squared plus 2. So don't forget about that. All right? The last section is when you have four terms, when you're doing grouping. And again, I'm kind of going through these kind of quickly because these are all worked out for you, and then I'll do some actual examples with you. When you have four terms, it's usually a huge thing to tell you to start grouping. So you group the first two and the second two terms together, and you factor out the greatest common factor in each one of those. And what happens is one of the factors becomes the sum or difference of these two numbers that you've taken out, and then the other factor is the one that ends up, so that you end up with in the parentheses for each one of these. So one of the things you want to be really careful of is that that these always end up being the same. So sometimes you have to be a little bit creative with that. Like right here, I had to factor out a -1. So definitely be careful. And also don't forget, you can still factor here when you have a difference of two squares, right? Those are the things, the difference of two squares are some of the easiest things to do and to learn, but they're sometimes the things that you forget the most. So that's why I try to put those in there. So be really careful of that. Okay? So let's go on. And then I also had this filled out for you guys just as a study guide. Just things to go back to: sum of two cubes, difference of squares, sum of two cubes, difference of cubes, trinomials, and stuff. And I wanted to show you my method of factoring a trinomial with a leading coefficient other than 1. So let me just go ahead and start working on some of these. I have a sum of two cubes here and a difference of two cubes here. And I have a difference of two squares right here. So first thing I'm going to do, I'm going to go ahead and walk you through this. I know this is a perfect cube. 1 is always a perfect cube. So I take the cube root of 8a to the third, and I get 2a, right? And then I take the cube root of 1, and that is 1. Now this is a sum. So as a reminder, you have a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. Okay? That's a plus. Sorry. Okay. So my a is this 2a plus 1, right? I square this first term, so that's going to be 4a squared. And then I multiply these two together. So I do minus 2a, and then I square the last term, which is 1. Okay? Now let's take a look at these difference of two squares. So the square root of x to the fourth is x squared. I know this is a perfect square because it has an even exponent. And the square root of 100y squared is just 10y. So that one ends up being pretty easy. I get x squared plus 10y and x squared minus 10y. And there you go. Nothing else to take out. All right. Now let's do a difference of two cubes. So this is a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. All right. Okay, so this one, I'm going to do the cube root of m cubed is just m. And the cube root of 64 is 4. So this is going to be m minus 4 times m squared plus 4 times m plus 16. Okay? Now this is where we need to be careful. I have a greatest common factor to take out. I have 3 and a w. So if I take out 3w, I get 9w to the fourth minus 25. Okay? So the square root of 9w to the fourth is 3w squared. And the square root of 25 is 5. So I have 3w times 3w squared minus 5 and 3w squared plus 5. Now we learn how to factor mainly because we want to be able to solve polynomials. And what we mean by solving polynomials is finding the x-intercepts of these, which help us graph them. So that's definitely something that you guys want to make sure you keep that in mind, that there is a reason for this. The better you are at it, it's going to get easier and easier, and the better you are at it, the easier future lessons are going to be. Now I'm going to kind of skip around here. I hope that's okay. And then I will also post these answers if you want them. Let's go ahead and factor out number 11 here. So the first thing I'm going to do is take out a greatest common factor. All right, so this becomes 8x times x squared minus 12x plus 36. And then what I do is I say, okay, what two numbers will multiply to 36 and add to negative 12? Well, that has to be a negative sum, and this is positive. I have two negatives, and that was not too hard. That's negative 6 and negative 6. Okay? So I end up getting x times x minus 6 times x minus 6, or I could have just done x minus 6 squared. The next one I'm going to do is right here. I'm going to first divide everything by 2. See how these are all even? I can factor out that 2 for you. So that's 2 times m to the 4th minus 5m squared minus 14. Okay, so then I say, okay, what two numbers multiply to a negative 14 and add to a negative 5? You get really good at your times tables when you factor, and that's going to be negative 7 and a positive 2. Okay, feel free to pause this at any time so that you can work this out yourself and then test and check to see how you do. Okay, so this is going to be 2 times m squared minus 7 times m squared plus 2. Now I can't factor these anymore. I always double check, especially when I have a square right there. Okay? Now what about this one? I want to take out a 5 first. Okay, so that's x to the 4th minus 2x squared and minus 315. 315 divided by 5 is 63. Now, I know what might be throwing you off is this 4th term and squared term. We're used to seeing things like x squared plus something times x plus 12, right? Or something like that. That could possibly throw you off, but just treat it like you would any other one. It follows the same pattern, and that's kind of why I wanted to go through some of these with you. Okay, so what two numbers multiply to a negative 63 and add to a negative 2? And that is a negative 9 and a positive 7. Okay, so I have 5 times x squared minus 9 times x squared plus 7. Now this is where we have to be careful. Do you see how these are a difference of two squares? So I have to take this a step further, okay? Because it has a degree of 4. It's going to cross the x-axis more than 2 times, right? So this is 5 times x plus 3 and x minus 3 times x squared plus 7. Okay? Because remember, when we're solving a polynomial, we factor it out and set the factors equal to 0 and solve for x. And those are x-intercepts. Okay? All right. Now let's try this one right here. I can tell these are all divisible by 3 because 8 plus 4 is 12 and 12 is divisible by 3. If you ever want me to go through some divisibility rules, just let me know. Okay, so I could take out a 3u here. So this is 3u. So, and that's times u to the 4th minus 3u squared minus, and then 84 divided by 3 is 28. So that's minus 28. Okay, so then, let's see, what two numbers multiply to negative 28, and add to negative 3. And that would be negative 7 and 4. Okay? 3u times u squared plus 4, and then times u squared minus 7. Now be careful. A sum of two squares is not factorable. In fact, if you set that equal to 0, you're going to get an imaginary solution, right? Plus or minus 2i, right? Okay, what happens when we can't take out a greatest common factor, but we should be able to factor these? Now, some of you have learned slide and divide, and I'll post a video on slide and divide that explains it a lot better than I do. So I'm going to go ahead and post that, but I'm going to show you the way that I do it. I do it by factoring by grouping. So this is what I do. I multiply this number times this last number right here. So that becomes a positive 60. And I say, okay, what two numbers will multiply to 60 and add to 16? Well, that's going to be, and this is where I get the 16 right here, right? And that's going to be 10 and 6. Okay, so what happens is now I turn this middle term into two separate terms. So I'm going to have 3a to the 4th plus 6a squared plus 10a squared plus 20. Now it doesn't matter if I put the 10 first or the 6 first. It really doesn't. So don't stress about that. So now what I'm going to do is group these terms together, and when I do that, I take out the greatest common factor in each one of these. All right, so here I'm going to take out 3a squared. All right, so that leaves me with an a squared plus 2. Then I'm going to take out a 10 here, so I'm going to take out a 10, and that gives me an a squared plus 2. All right. So then my new factors are 3a squared plus 10. I got that from here and here. And then I get a squared plus 2. All right. And we're all factored. And like I said, I will show you slide and divide as well, but I'm going to do a video with somebody else doing it because like I said, I think she does it much better than I explain it, to be honest. And I usually prefer this method, but either way that you do it, if you're comfortable with it, it's totally fine. All right, so here's the other thing. Let's try this one. 8 times negative 1 is negative 8. So what two numbers multiply to negative 8 and add to negative 2? That would be negative 4 and positive 2. Okay? So now those are my two new middle terms. So I have 8n to the 4th minus 4n squared plus 2n squared minus 1. So I want to take out the greatest common factor here. So I'm going to take out 4n squared and I get 2n squared minus 1. Now, do you notice that this is exactly the same as this? Well, I can still take out a factor, and I can take out the factor of 1 because I have to have two numbers here. So it's going to be 1 times that, right? So I'm going to get 4n squared plus 1. Oh, Lord. Plus 1 times 2n squared minus 1. All right? Definitely wanted to spend some time going through those. And like I said, I'll post some slide and divide videos if you'd like to slide and divide. All right? Then the next thing we do is we're going to do factoring by grouping. And we have a bunch more practices, so that's good. So we're going to do some factoring by grouping here. So I'm going to go ahead and work on number 18 first, and then I'll work on 20, and we'll probably leave it at that. So here I'm going to take out a 3b squared. So 3b squared times 2b minus 1, right? And then here I'm going to take out a 2, and that's going to be 2b minus 1. So my two factors are 3b squared plus 2 times 2b minus 1. Okay? Remember to always check for greatest common factor first. As right here, I can't take out a greatest common factor, so I'll go through these next two for you. And then hopefully that'll give you guys some time. If I need to, I'll do some more of this too. Okay, so here I'm going to take out 2w squared, or w squared, I apologize. So w squared times 2w plus 3. And then this is a minus 6w, so I'm going to take out a negative 3. Because I need this to be positive and this to be positive, right? Because these guys have to match. So then I get a 2w plus 3. Okay, so I get w squared minus 3 times 2w plus 3. Okay, next one I'm going to do is factor out x squared. So I have x squared is equal to x cubed plus 5, not a sum of two cubes, so I don't have to worry about that. And then minus 4 times x cubed plus 5. But what do we have here? X squared minus 4 times x cubed plus 5. This is a difference of two squares. So I'm going to do x plus 2, x minus 2 times x cubed plus 5. Okay? So that's a good 22 minutes of doing some factoring. If there's some more problems that you want, send me a message through Edmodo and I'll work through them for you on another video. I know that there's a whole nother page of you guys, so please feel free to work together on these if you need to, but I just want you to get really good at factoring, okay? So hopefully that gives you a good start to what we're doing. Have a good week, you guys, and please be good for my sub.